first example. Example 1. A can of tennis balls has a height of 9 inches and a radius of 2 inches. The tennis balls have a radius of 2 inches. Calculate the volume that is not being used up by the tennis balls. So if you've ever played tennis or been in, a sporting goods store, maybe you've seen how tennis balls are sold, and there's 3 of them inside of one cylinder can. So the first thing we want to do is look at what shapes we have. So the outside, the can that it's in is shaped like a cylinder. So I'm going to list that, cylinder. So we'll need to find the volume of the cylinder. And then each of the tennis balls inside are shaped like spheres. I almost spelled that wrong, S-P-H. And then we can't forget, there's not just one sphere inside, there's 3. So we also need to remember to do times 3. All right, so let's first start with our cylinder. So we want our volume formula for a cylinder. Volume equals pi, and it doesn't tell us, but let's use 3.14 because that's what all your practice problems have, times the radius squared times the height. All right, so let's go back up to our problem here and fill in our value. So it's the can of tennis balls has a height of 9 inches. So 9 inches is the height of the cylinder. All right, and then the radius of the can, so from the center to the outside, is 2 inches. All right, so that's the info we need to find the cylinder, so let's do that first. So 3.14 times the radius of the can is 2, so 2 squared, times the height of the can is 9. All right, so we are going to use our calculator here. 3.14 times 2 squared times 9. So 3.14 times 2 squared times 9. And that gives us 113.04. 113.04. And we want to round that to the nearest tenth. So the 0 looks at the 4, and the 4 tells it to stay, so 113. You could put decimal 0 if you want, or you could just put 113 because that's the same. Okay, I'm going to go ahead and put decimal 0 just in case. All right, now let's calculate the volume of the sphere. So that's inside, and it tells us the tennis balls have a radius of 2 inches. So I'm going to draw inside radius of 2 inches of each of the tennis balls. All right, so let's write our formula for sphere. V equals 4/3 times pi. Again, we're going to use 3.14 because that's what your practice problems have you do. Times the radius cubed. Remember, the formula for a sphere is radius cubed, where it's squared for the cylinder and cone. So can't forget that part. All right, so we're going to use our calculator. Well, let's fill in the blanks. V equals 4/3 times 3.14 times the radius of each tennis ball was 2 to the 3rd power. All right, now I'm ready to use my calculator. So this time we're going to do 4/3. So 4/3. Remember, you can just do 4 divided by 3 if your calculator doesn't have the N/D button, times 3.14 times 2 to the 3rd power. Remember the little caret to the 3rd power, and press enter. 33.49. V equals 33.49, and we're rounding to the nearest tenth. So the 4 looks at the 9, and the 9 tells it to go up. So 33.5, and I need to put my units. This is all inches cubed, and this is also inches cubed. All right, so now we know the volume of the can, the cylinder, is 113 inches cubed, and the volume of one sphere is 33.5 inches cubed. Now we need to find the volume of all 3 tennis balls because they're all 3 taking up space in the can. So we're going to do 33.5 times 3. Okay, so let's go back to our calculator, and we're going to do 33.5 times 3. Notice that I didn't use the long extended multiplication. I use the rounded times 3. So you got to make sure you do that in your problem or you won't get the same answer that counts it correct. So 3 tennis balls is 100.5. So the volume of 3 equals, ooh, let me look one more time, 100.5. 100.5 inches cubed. All right, so we have the volume of the can, we have the volume of 1, and then we have the volume of 3. Now we're still not finished because we come back up here, find the volume that is not being used. So this is where the subtraction comes into play. We're going to take the volume of the can, 113.0, and we're going to subtract the volume of the tennis balls, 100.5. And you can use your calculator. Let me clear it. 100 and I can't even remember. 113. Whoop. One more time. 113 minus 100.5. And that gives us 12.5. So the volume of the unused space equals 12.5 inches cubed. So that's the amount of space inside the can that is not being used. We found the volume of the cylinder can, then the volume of one sphere, then we multiplied that by 3 to find the volume of all 3 spheres, then we subtracted that from the volume of the can to get the unused space. So today we're looking at multi-step problem solving with volume. So we're using the skills that we have learned about finding the volume of cylinders, cones, spheres, and hemispheres, but now we're going to apply that and have to solve problems that involve multi-steps. So it's like application applying. All right, so let's do an example together. Here we go. Example 1. Safety barrels are used on some highways to cushion cars on impact. All right, so safety barrels, you may have seen them on like Georgia 400 or on roads where there's construction. These are examples of these. They're yellow, but the ones that we typically see here in Georgia are orange, and sometimes they'll have a little reflector on the top. So those are safety barrels. All right, I'm going to keep reading. If a city manager approves the purchase of 15 cubic meters of sand, how many barrels can be filled with sand? Use 3.14 for pi. All right, so then we have a picture here, like I said, of the barrels. And this first caption on the left tells us the height is 1.2 meters. And the caption on the right says the diameter is 0.9 meters. So we know the height and we know the diameter. All right, so if we know that he has 15 cubic meters of sand and we got to figure out how many of these barrels he can fill up, we first needed to figure out how much each one of the barrels can hold. So that, of course, is finding the volume of the barrels. So the shape of the barrels is a cylinder. So that means we're going to be finding the volume of a cylinder. So let's find that first. So our formula, let's write it down. Volume equals 3.14, because it says use 3.14 for pi, times radius squared times height. So now we're going to fill in our numbers. 3.14 times radius squared, and we only have diameter here. We have that diameter equals 0.9. So we first need to find what r is. So we know that radius is half of diameter. So we want to go to our calculator 0.9 divided by 2. So because we want to half it. So 0.45. So the radius is 0.45. All right, so 0.45 squared times, and then the height is 1.2. So times 1.2. All right, so now we're ready to put all this in our calculator. 3.14 times 0.45 squared times 1.2. Okay, let's see if I can remember that. All right, I'm going to clear it. So 3.14 times 0.45 squared times, what was the height? 1.2. 1.2. 3.14 times 0.45 squared times 1.2 equals 0.76302. So let's round. And for this one, I'm going to go to the hundredths place. So that's between the 6 and the 3. So the 6 looks at the 3 and it tells it to stay. So 0.76. So I'm going to make this approximately 0.76. And this is meters cubed. All right, so this is the volume of one barrel. But we know that we need to figure out how many, oh, I spelled that wrong. It only has one L. There, B-A-R-R-E-L. So we want to figure out how many barrels we can fill if we have 15 cubic meters of sand. So one barrel doesn't even hold a whole cubic meter. All right, so if we want to figure out how many it'll take to hold 15, then we're going to divide. So we're going to do 15 cubic meters divided by how much one barrel holds, 0.76. So let's go to our calculator. 15 divided by 0.76. And to get accurate, we could actually put the 302 from what we got, or we can just leave it 0.76. So we get 19.73. Let's see if we get different if we do the whole thing. 15 divided by 0.76302. We still get 19 decimal. Okay, so 19.736. So 74. 19.74. All right, so how many barrels can be filled with sand? Almost 20, but not quite. So the answer would be 19 barrels can be filled with sand. And really, 19.74 would be part of a barrel. So 19 whole barrels and then part of one. And that's kind of how you solve. So you're finding volume of something, but then you have to answer a question with the second step. So in this case, we had to divide to see how many we could fill up. Okay?